Hello everyone. Welcome to the series where we are covering quantitative aptitude questions from previous year UPSC CSAT papers. In the previous few sessions we covered questions on number system from 2016 to 2019. And in this session we will cover questions on number system from 2020. See, this session is going to be very important as there were almost 15 questions on number system. Okay, so let's begin with the questions. Now, question number one is how many zeros are there at the end of the following product? Now, we are given some numbers and we need to find how many zeros will be there in the final product. Okay, now we know that we get a trailing zero. Okay, if we multiply a number by 10 or by a pair of 2 into 5. Okay, now let's write down all these number in the form of factors. So we can also write it 1 into 5 into 2 into 5 into 3 into 5, then 2 into 2 into 5, then 5 into 5, then 2 into 3 into 5, then 5 into 7 into then 2 2 2 into 5. Again we can write 3 into 3 into 5, then we can write 2 into 5 into 5, then we can write 5 into 11, and similarly we can write 2 into 2 to 5. Right, now let's see how many 2's and 5's are there in the above product. Okay, now number of 2's is equal to 10 and number of 5's is equal to 14. Okay, now pairs of 2 into 5 will be 10. So we will get 10 zeros at the end of the final product. So right answer is A here. Let's move to question number 2. Question number 2 is x, y, z be a 3-digit number where x plus y plus z is not a multiple of 3, then x plus y plus z, y z x plus z x y is not divisible by. Okay, so we need to find by which number this sum is not divisible. Okay, now let's again write these numbers in the expanded form. Okay, and the number will become 100x plus 10y plus z plus 100y plus 10z plus x plus 100z plus 10x plus y. We can write this sum in this form. Again, we can also write it as 111 x x plus 111 y plus 111 z. We can take 111 111 common, it will be x y plus z. Now the factors of 111 are 3 into 37, and now we can also say that this is a multiple of 337 and x plus y plus z. So this number will be divisible by 3, 37 and x plus y plus z. Since this number, we are also given that this number is not a multiple of 3. That means this number will not be divisible by 9. Okay, so right answer is B here. Let's move to question number 3. Let P, Q, R and S be natural numbers such that P minus 2016 is equal to Q plus 2017 is equal to R minus 2018 is equal to S plus 2019. Which one of the following is the largest natural number? Okay, now first let's compare P with R. Okay, now for that P minus 2016 is equal to Q plus 2017. It will be P Q plus 7613. Okay, then we have, it will be 4033. Okay, now this implies that P is greater than Q. Okay, now let's compare P with R because P is greater than Q. Okay, now we will compare P with R. Now for that P minus 2016 R minus 2018. Now P is equal to R minus 2018 plus 2016. It will give us R minus 2. Okay, that means R is greater than P because when we decrease R by 2 then it will be equal to P. So here R is greater than P. Now finally we compare R with S. For that we write R minus 2018 is equal to S plus 2019, and again it will be S plus 2019 plus 2018. It will be S plus 4037. Okay, so R is greater than S. So R is the largest number here. Right answer is C here. Now question number 4 is how many 5-digit prime numbers can be obtained by using all the digits 1, 2, 3, 4 and 5 without repetition of digits. Okay, now we know that a prime number is a number that is not divisible by any other number except 1 and the number itself. Okay, now we have the digits 1, 2, 3, 4 and 5. Let's form any number using these digits. Say we have a number 2, 1, 3, 4, 5. Now sum of all the digits of this number is 15, and 15 is divisible by 3. Now according to divisibility rule, if the sum of the digits of a number is divisible by 3, then that number will be divisible by 3. That means this number is divisible by 3, or we can say any number formed using these digits will always be divisible by 3. That means we cannot form any 5-digit prime number by using these digits. Okay, so answer is A, 0 here. Okay, so question number 5 is in the sum we are given an equation. Okay, and we need to find a value of the symbol which satisfies this equation. Suppose the given symbol is x. Okay, we rewrite the equation and we can write it like 1x x plus 1x, then 5x plus x into x, then x1 is equal to 1 x. Okay, now let's write these numbers in the expanded form. It will be x, it will be 10 plus x, it will be 50 plus x, it will be 10x plus x, and it will be 10x plus 1, it will be 100 plus 10x plus x. Now let's count x terms on the left hand side. It will be 1 2 3 13 14 24, 24x plus 61, 10 50 50 plus 1 is equal to, here we have 100 plus 11x. Now we can also write it 24x minus 11x is equal to 100 minus 61, it will be 13x, it will be 39, x will be 3. Okay, so right answer is B here, 3. Now question number 6 is a simple mathematical operation in each number of the sequence 14, 18, 20, 24, 30, 32 results in a sequence with respect to prime numbers. Which one of the following is the next number in the sequence? Okay, so the given numbers are 14, 18, 20, 24, 30 and 32. Okay, now if we closely analyze this number, okay, then we can say it is 13 plus 1, it is 17 plus 1, it is 19 plus 1, and this is 23 plus 1, again this is 29 plus 1, and this is 31 plus 1. Okay, now we see that these numbers are prime numbers: 13, 17, 19, 23, okay, 29, 31. Okay, these are all, these numbers are prime numbers, and the next prime number in the series will be 37, and the next number in the given sequence will be 37 plus 1, 38. Okay, so right answer is C here. Let's move to question number 7. We are given two 4 digit number. Let A3, B, C and D, E, 2F be 4 digit numbers where each letter represents a different digit greater than 3. If the sum of the numbers is 15902, then what is the difference between the values of A and D? Okay, first of all, let's write these numbers in the form of sum. That it is A3, BC and DE, okay, 2F. If we add both these numbers, then the sum is 15902. Now according to the question, A, D, E, B, C, F, all these letters represent a digit which is greater than 3. Okay, and all the letters represent a different digit. Okay, now if we see here in the sum, we have 2 at the units place. That means when we add two digits C and F, we get 2 at units place. That means C and F can be either from 4 or 8 or 5 or 7. Right? Now when we add C and F, we get a 2 here and we get a carry over here. Now 1 plus B plus 2, okay, we get a 0 here and we must get a carry over here. uh, let's say when we add 1 plus B plus 2, and it must be 10. Okay, now B is equal to 7, Okay. Now if B is 7, that means C and F are from are 4 or 8. Okay. Okay. Now we have used 4, 8 and 7. The remaining digits are 5, 6 and 9. Okay. We have used 7, 4, 8 and now we are left with 5, 6, 9. Okay. Now next is 1 plus 3 plus E is equal to 9. Right. Now E is equal to 9 minus 4 gives us 5. Right. Now we have also used 5. We are left with 6 and 9. That means A and D can be 6 or 9. Okay. Either A can be 6 or 9. Similarly, D can be 6 or 9. But the difference will always be 3. So right answer is C here. Now question number 8 is two statements S1 and S2 are given below with regard to four numbers P, Q, R and S followed by a question. Statement S1 is R is greater than P as well as Q, and statement 2 is S is not the largest one. And the given question is among four numbers P, Q, R and S, which one is the largest? Okay. First of all, let's try to solve this question with statement S1 only. Okay. Now, according to statement S1, R is greater than P and R is greater than Q. But we cannot for sure say that R is greater than S or R is less than S. So we cannot answer the question with statement S1 alone. Now let's try to answer the question with statement S2 alone. S2 is not the largest one. Okay. So with statement S2 we cannot answer this question. Okay. Now let's try to solve the question with both the statements. Okay. Now R is greater than P, R is greater than Q. Again, S is not the largest one. Since S is not the largest number, so R must be the largest number. Okay, because S is either less than P, less than Q, okay, or less than R. But it is not the largest one. So R is the largest number. Okay. So here answer is S1 and S2 together are sufficient to answer the question, but neither S1 alone nor S2 alone is sufficient to answer the question. Okay. Question number 9 is two statements S1 and S2 are given below followed by a question. Okay. Then statement 1 is n is a prime number and statement 2 is n leaves a remainder of 1 when divided by 4. And the given question is if n is unique natural number between 10 and 20, then what is n? First let's try to solve this question with statement 1 alone. Now according to statement 1, n is a prime number, but there are four prime numbers between 10 and 20 and these are 11, 13, 17 and 19. Okay. So statement 1 alone is not sufficient to answer the question. Now let's see, can we answer the question with statement 2 alone? N leaves a remainder of 1 when divided by 4. There are more than 2 numbers which when divided by 4 give us a remainder of 1. Okay, so even statement 2 is not sufficient alone to answer the question. Okay, now let's try to solve the question with both the statements together. Okay, now see, n is a prime number. We have 4 prime numbers here. Now n leaves a remainder of 1 when divided by 4. Now when we divide 13 by 4, we get a remainder 1. Now when we divide 17 by 4, we get a remainder 1. But okay, now we cannot answer what is the value of n here, right? So even with the help of both the statements, we cannot answer the question. So answer is D here. Now let's see question number 10. Two statements S1 and S2 are given below with regard to two numbers followed by a question. Statement 1 is their product is 21 and their sum is 10. And the question is what are the two numbers? Okay. So let's suppose the two numbers are A and B. Right. Now according to statement 1, their product is 21. We cannot solve this question using statement 1 alone. Similarly, we cannot solve this question with the help of statement 2 alone. Okay, right. Now let's try to solve this question with the help of both the statements, right? So statement 1 is A into B is equal to 21. Let's say this is equation 1. Now A plus B is equal to 10. This is 2. Now let's say B is equal to 10 minus A. Now let's write and let's substitute the value of B in equation 1. It will be A into 10 minus A will be 21. Now it will be 10A minus A square. Okay, it will be 21. We can also write it A square minus 10A plus 21 is equal to 0. We can also write it like A minus 7, A minus 3 is equal to 0. Now A is equal to 3 or A is equal to 7. Now if A is equal to 3, then we can find the value of B from equation 1. B will be 7. If A is equal to 7, B will be 3. Okay. So we can find the two numbers and these are 7 or 7 and 3. Right. So both the we can so here answer is C. S1 and S2 together are sufficient to answer the question, right? But we cannot solve this question with statement 1 alone or statement 2 alone, right? Let's see question number 11. How many integers are there between 1 and 100 which have 4 as a digit but are not divisible by 4, right? According to the question, how many integers are between 1 and 100 which are not divisible by 4 but have 4 as a digit? Okay, so first of all let's write how many numbers are there between 1 and 100, okay, which have 4 as a digit. So these numbers can be 4, 14, 24, 34, okay, then 44, then 54, 64, 74, 84 and 94. And now 4 can appear at tens place, then the number can be 40, 41, 42, 43, 44 we have already covered, right? Then we have 45, 46, 47, 48, 49, right? So how many number are these? These are 20, right? Now let's see how many number are divisible by 4? This is divisible by 4. This is divisible by 4. Okay. This is divisible by 4. Again, this is divisible by 4, right? And this is divisible by 4. Then this is divisible by 4. Okay. Now remaining numbers are 1, 2, 3. See, 64 is also divisible. Okay. Now let's count the numbers. 1, 2, 3, 4. Again 5. Then 6, 7, 8, 9, 10, 11 and 12, right? So answer is C here. Okay, let's move to question number 12. The recurring decimal representation 1.272727 is equivalent to, suppose the given number is equal to 1.272727 and so on. Okay, now let's multiply this number by 100 both sides. Let's say this is 1. Now if we multiply it both sides, it will be 127.27, sorry, 0.27, 27, then 27 and so on. So this is equation 2. Let's subtract equation 1 from equation 2. Okay, it will be 99x is equal to 126. Now x will be 126 but at 99. Okay, and it will be, right, if we divide it by 9, it will be 11 and it will be 14. It will be 14 by 11. Okay, so right answer is B here. Let's move to question number 13. What is the largest number among the following? We are given 4 numbers here and we need to find the largest out of these. Okay, now 1 upon 2 raised to power minus 6 can be written as 2 raised to power minus 1, 2 raised to minus 6. It will be 2 raised to power 6. It will be 64. Similarly, 1 by 4 raised to power minus 3 can be written as 2 raised to power minus 2 minus 3, and it can be written as 2 raised to power 6 again 64, right? Now 1 raised to power 3 raised to power minus 4, we can write it 3 raised to power minus 1 raised to power minus 4. It will be 3 raised to power 4 and it will be 81. Again 1 raised to power minus 1 raised to power 1 upon 6 raised to power minus 2 will be 6 raised to power minus 1 raised to power minus 2. Okay, it will be 6 raised to power 2, it will be 36. So 1 upon 3 raised to power minus 4 is the largest number here. So answer is C here. Let's move to question number 14. What is the least 4-digit number when divided by 3, 4, 5 and 6 leaves a remainder 2 in each case? Now first of all, let's see what is the LCM of 3, 4, 5 and 6. Okay, right. 1, 2, 2, 5, 3. Right. Now 1, 2, 5, 3, 1. Okay. Now we can see LCM is equal to 60. Right. Now the least 4-digit number is 1000, and when we divide 1000 by 60, okay, when we divide 1000 by 60, okay, it we get 40. Okay, 10. Okay, now we get here 40 as remainder, right? That means we need to add 20 to 1000 so that it is divisible by 60. Now if we add 1000 plus 20, now this number will be divisible by 60. Okay, right? Now if we add 2 here again, we will get a remainder when we divide this number by 60. Okay, and we also get a remainder of 2 when we divide this number by 3, 4, 5 or 6. Okay, so answer is, it is 1 0 22. Okay, now question number 15 is, what is the remainder when we divide this product by 100? Okay, now we can write this in the form 51 into 27, 135, 62 into 75. Okay, divided by 100. Now let's cancel out common terms. First let's divide by 5, it will be 15, it will be 20, we cancelled out with 5, then it will be 7, it will be 4, we cancelled out with 5, now again it will be 2 and it will be 31, right? Now we cancelled out with common term 2. Now we can see this here, if we divide 51 by 2 we will get a remainder of 1. Similarly, if we divide 27 by 2 we get a remainder of 1, and here again we get a remainder of 1. When we divide 31 by 2, again we get a remainder of 1, and similarly when we divide 15 by 2 we get a remainder of 1. Now when we divide this number 1 2 3 4 5, okay, by 2 we get a remainder of 1. Now overall, what is the remainder? Overall remainder will be 1 into 5 into 5 into 2, it will be 50. So right answer is A here. Okay, so that's all for today. We solved some questions from UPSC CSAT paper 2020, and these questions were on number system. If you like the session, please share, subscribe and support our channel. Thank you.